Hello, and we're live for another LXD release live stream. This week it's gonna be LXD 5.5. And just checking that everything looks good on my end. Seems fine. Cool. I know actually a few of you ended up commenting on some past videos about the cat, so the cat is back to sleeping on the desk. For a while he was sleeping on something on the floor instead, so you couldn't see him on the videos anymore. But yeah, he's back, and I don't know, maybe he's gonna turn around or something at some later point in the video. Who knows? Anyway, he's back. All right. Back to actual LXD matter. So LXD 5.5 was released late last week. This is a bit of a busier release compared to what we had in the past. That kind of makes sense because the larger features, so our release cycle at Canonical starts usually in May and goes up until late October, early November as far as kind of timeline. And then we do another one from November going into end of April. And so our cycle this year started effectively, mid to late May-ish. And then there's the summer where a bunch of people are off, kind of on and off and everything. So it takes a little while to write down some specifications, agree on new features, actually figure out exactly what it is you would do, doing some research, and then actually implementation before things start showing up into releases. So that means the first few releases, especially after an LTS like LXD 5.0, we're primarily focused on bug fixes and kind of refactoring and stuff ahead of upcoming work. And yeah, this release is a bit more busy. The main new feature we've added are storage buckets. So this is going to be rolling out across all storage drivers inside of LXD, but right now we have it just for Ceph. It allows creating effectively your kind of normal S3 object storage type bucket. You can create that on top of LXD. It's kind of going parallel to volumes as far as how we treat things within LXD. And once you created a bucket, you can create some keys and then access using a normal S3 API that particular bucket and put files, push files, or whatever you want in there. This is like LXD itself doesn't consume object storage, but it's a facility that's provided to our users. It's again like LXD's main goal is to be kind of your own public cloud, like as far as many of the services. That's why we've got things like load balancing, floating IPs, all that kind of stuff. And the same is true with storage. So now that most of the public clouds have some kind of object storage, they tend to use the S3 API or some variation of it. So LXD has the exact same thing now, and we're going to be adding support for the rest of the storage drivers shortly. As far as consumer, this is usually going to be consumed by whatever application you might run in your containers or in your virtual machines. Applications will use that kind of object storage for things like user uploads, for sometimes some caching, backups, that kind of stuff. So if you're using an application that can make use of that kind of storage, then that's something you might want to look into. The next one is something that's been requested a fair bit over the years. Effectively, with LXD, the way LXD treats its instances is that it doesn't care about what's inside of them. And in general, that means that we treat an instance as being running as soon as we have started it. And for a container, starting means we've spawned the init system. For a virtual machine, it means we've started QEMU that then starts the firmware and all that kind of stuff. It being running doesn't mean that it responds. It doesn't mean that it actually has any services running. It doesn't mean that SSH is up. It doesn't mean any of that. And that's been the source of issue for some users that then have to use different tricks to kind of try to go around that. The most obvious trick would be kind of running a loop of LXC exec and kind of running commands inside of the instance to see whether it's ready or not. So you can run LXC exec, like cloud init, wait, or whatever it is to wait for cloud init to be done. There have been multiple ways you can do it, and that's been done before by many users. But we figured there might be a cleaner way, and that's kind of what we've done here. Effectively, what we do is we extended our existing API that's exposed to the guest itself to allow the guest to tell us that it's ready. And yeah, the way you do it is you access the API and you set your own state. So you can say, okay, this instance is now ready. And once you've done that, then the state in the LXD API turns to ready as well. That makes it significantly easier to check from outside of the instance. It does mean the instance itself needs to know whether it's ready or not, and then needs to make that call to set its status. But it also means you can define ready whichever way you want. Like for some users, ready just means, okay, SSH is up. Some others, it means whatever service you're running in there is up. So you can really kind of customize that whatever way you want, and you've got that facility there that you can now make use of within LXD instances. Then we've got some smaller things. For BGP, so for those of you who are using that to advertise route within LXD or LXD clusters, there's now a flag that is to control the BGP hold time. So that's effectively the internal timeout that BGP will use before considering a peer to be completely dead and dropping everything. The default in the industry tends to be Cisco's default, which is 180 seconds. This setting lets you reduce that considerably if you want. So that's a nice user contributed setting right there. The next one we got is the ability to retrieve storage volumes across multiple projects. So this lines up with what we've done in the instances API some time ago. And that's particularly useful for applications that are driving LXD or LXD clusters and want to get an overall view of everything that's going on. It's possible to do that API query and actually see everything. There's also a CLI version of it, which I've not showed in the announcement, but I will show in the demo. And then we've got also a small tweak to our metrics. I think it was also user contributed. So we had a user that was running into out of memory issues where instances would hit the out of memory threshold, would get processes killed, but it wasn't necessarily obvious what happened. The process just dies, and you need to look at the kernel log to figure out what happened. But then a privileged user doesn't have access to the kernel log usually, so it's pretty opaque. But there are counters in the kernel that can be accessed, and that's now being exposed. So if you're using the LXD metrics API with something like Prometheus, now there's going to be a metric counter that you can access, which tells you how many times the out of memory killer has been triggered on a particular instance. So if you see any number higher than 0 probably hints at an issue with whatever's running in the instance, and any very high number will mean that that instance is effectively hitting memory limits over and over again and keeps having processes be killed. So that's another pretty useful one. And something else we've done, mostly to deal with issues by the number of users reported, is we've taken a pretty close look at a lot of our database interactions and done a lot of work to optimize them, removing code paths that were not fast at all, but were used in a bunch of places within LXD. So we've done that. Also optimizing our database generator and general patterns within our database to make things a fair bit faster. You're mostly going to notice that when dealing with instance listing, background tasks that needs to pull the list of all instances, and for things like instance snapshots. That can be quite a bit faster. It will mostly be noticeable for cluster users with hundreds to thousands to tens of thousands of instances in snapshots. But yeah, that's quite a noticeable bump. We're also still looking at a bunch of other kind of database related things. We're not at a perfect point yet. There's still a bunch we can do, a bunch more performance we can try to pull out of our database. But for the very vast majority of users, this is not going to be noticeable. The performance was pretty good and will be just as good now. All right, so that's the list of features. Now I'm going to go over to a terminal and play with a bunch of those. So just switching. There we go. And for this one, I get to actually pretty much show everything from my own machine, which is a bit of a change from past ones. That's primarily because we don't have anything that's cluster related in this one. The closest thing we've got to a cluster related feature would be the storage bucket, which is restricted to Ceph, and Ceph is often used by cluster users. But that is not the case here. I'm just on my normal machine, which is not clustered. And I've got a Ceph cluster that I can make use of, which I'm going to be using here in the demo. So the first thing to do when you want to play with with Ceph and object storage is that it's a new storage driver type. We had to do that because of the way Ceph works. Ceph effectively has three components, or three types of storage it can provide. Ceph Rados block device, which are the block devices used by normal instances in some custom volumes within LXD. That's the driver that's called Ceph. Then we've got Ceph file systems, which is a networked file system that can be shared by multiple instances across multiple systems. That's the Ceph FS driver. And now we've got Ceph object storage, which we've made a Ceph object driver for to kind of match the existing pattern. This is mostly needed because we can't have one driver that provides all three at once, since within Ceph, you can structure things in different ways. You might be using different OSD pools to segment your data in different ways, do some kind of replication policy on one or the other. So it makes a lot more sense to also segment things in LXD, even if that means 3 storage drivers just for Ceph. So I'm going to be calling my storage driver remote dash object, and the driver, as I said, is called Ceph object. And then what we need to specify is the Rados gateway endpoint. So effectively for object storage, Ceph runs an additional service called the Ceph Rados gateway, or RGW. This listens on the network, provides an S3 compatible API, and is what LXD will make use of for its clients. So in this case, you need to set what the endpoint is. And for me, it's something like that, and then a default port. This is using HTTP, but could be HTTPS. I just went the lazy route, and apparently I also made a typo somewhere. Ceph object, Rados gateway, endpoint. Oh, actually, I think it might be a typo within LXD. Okay. So I'm looking at my note and we've got a GSW, which I think is supposed to just be GW. So that looks like a typo we're going to be fixing. So in the current LXD, go with the typo. I think that matches our documentation, I hope. And we're going to be fixing that very shortly because that should be Rados GW for gateway. All right. So that's the pool created. Now that we've got the pool, and I can show that here. So I've got my default pool that's ZFS local, then the remote, I've got a remote pool, Ceph RBD, and then another one that's remote object. There is currently no use of the remote object one. The first thing to do now is going to be creating a new bucket. So I said there's a new command kind of mimicking the same structure as volumes. It's LXD storage bucket in this case. And then you can do a create and the pool name. So it's remote object, and it's called the volume foo. And that created the volume. Now, if we do a show on, sorry, not volume bucket. If I do a show on the bucket, it gives me its URL here. At this point, there's no way to access it. That's something we'll also change by default. Right now, there's no key generated, but we're gonna be changing that shortly so that you do get a key out of the box. And so you don't have to manually create your first key. You'll still need to use that if you want to rotate keys, or if you want a different kind of access pattern for a key. But it will save you from running this command, which just creates an initial bucket key. Anyway, so at this point, if I do show again on there, I've got its URL and I've got the access keys. So I can actually start doing stuff. I'm going to be copy pasting a very long command because it's very long. Here. So it's a command line client called S3CMD that's meant to interact with Amazon S3. And then I put the ISO image. In this case, it's a Windows ISO image I've got around, mostly because it's large. It's 4 gigs and doesn't compress well, so it's a good demo. Then there's the host that's specified here, so that matches the one returned by LXD. The bucket name is mentioned here in the S3 URL. And then you need to specify the access key and the secret key. So I'm just going to copy access key and I'm copying secret key. And parameter problem, nothing to upload. Okay. Oh, well, that's convenient. I deleted that file. Okay. So, I do happen to have it here. Cool. Okay, let's just move it back. Okay, and I'm going to be running S3 put. The S3 API is somewhat interesting because it doesn't let you upload anything that's larger than 4 or 5 gigs in one chunk. The S3CMD tool by default will chop things into 1 gig chunks, into 15 megs chunks, and because that would be extremely slow in this case. I changed it to use a 1 gig chunk instead. And we can see here it's starting to upload, and it's gonna have to do 5 chunks that way. It's not pushing super fast. The S3 CMD tool is not the most optimized. There's actually a better one, apparently, called S5. Sadly, I could not make it work with the Ceph Rados gateway for some reason, so I'm stuck with S3 CMD. The upside is that S3 CMD is still pretty fast for download. It's just the upload that's a bit slower than it should be. In this case, I'm on my desktop machine here, but I've got 10 gigabit networking to my basement with my rack, where I've got a bunch of servers, and that Ceph cluster is all on 10 gigabit and should be able to provide far more throughput than this. Like, I would expect to be able to push things at probably 200 or 300 megabytes per second if it wasn't for that command line tool being a bit slow. Probably not a problem that most people will actually run into. It's just I kind of like being able to show the best performance you can get out of something, and that's not gonna be it. That S5 CMD tool I mentioned is actually reporting to work at up to 40 gigabit speed, which would have been pretty sweet to look at. Anyway, the 4th chunk is being uploaded now, and then we should be left. I'm not sure if we've 6th chunk total is showing. Okay, so we still have this one's finishing. We've got a full one afterwards, and then a very small last one. After that, we can try retrieving the file, and that should go significantly faster than this. To be fair, for anyone with a spindle disk, this is not bad. I mean, 40 something megabyte per second is what you get on a normal hard drive. It's just we're all used to SSDs these days, and yeah, that could be faster. Okay, and the last chunk, it's just 300 megs, so that should go pretty quick. And there we go. Okay, so that's now in all uploaded, and to fetch it, we use the get command instead. Again, I need to fill in the secret and the access key here, and that will download it instead. Now we get some pretty decent performance. I still think a more optimized client could get a bit more performance out of it, but like 250 megabytes per second is pretty darn decent. Just a quarter of the bandwidth available, but it's pretty good. And there we go. So that used the bucket to like push a pretty large file, fetch it, and that's pretty much what we have in LXD. So I'm gonna be now just cleaning that stuff up. So doing that, then deleting the bucket. And because I don't actually, well, I might actually just keep the storage pool. I was gonna say I could also delete the storage pool, but I might just keep it around, maybe convenient. That also means that anyone who saw that URL and the access keys and who might have tried to access the bucket or put something in there or whatever while I was doing the demo, well, now the bucket is gone, so you can't do that anymore. Not sure if anyone tried, but you could have. All right, so that's for the object storage. The next one I would like to demo is the ready state. So for that, let's look at an instance. I've got U1 here, which is currently running. And if I go inside of U1, I think I've got curl installed already. So let's see, Unix socket dev LXD sock. So that accesses the dev LXD API, so our guest-facing API. And in here we can see state says started, and that matches effectively the running state we have. Now we can do same URL, but do a patch request instead, and then give it some input. And for that, we'll do state and set state to ready. Okay. If we query it again, you can see it says ready now. And if we query it from the host, same deal. And I think I've got the VM running too. I do. What's the state of that one? Running. Okay, cool. So VM and then run the same request, run it again, ready. So that's pretty much all there is to it. The ready state is pretty straightforward to use using the devlxd API. You can, if you've got curl installed, you can literally put that command in like an RC local script or something like that in your instance, and when that runs, it will just mark the instance as ready. Makes it quite a bit easier to figure out what's going on your system. and can also be used by like downstream software wanting to drive LXD. That could be useful. All right. And now let's look at storage. So I mentioned I'm going to use the REST API first, but we can access the list of volumes in LXD with this. That shows a bunch of instances. They're all in the default project in this case. That's why none of those here show any kind of like question mark project equals. You can query a specific project. Just look at my project list here. Okay, project say Snapcraft. Yeah. So if I do this, it now filters just the Snapcraft project. And now if I want all of them instead, I can do all projects true. And that gets me my entire list of volumes, including those from external projects. So that's pretty much what they illustrate as far as the API. On the CLI front, that should be just as easy. So if we list the default storage pool, that's here, and we should be able to do all projects. There we go. And we get the extract column telling us what project it's in and showing the volumes. So that's that feature. And the last feature I can easily demo is gonna be the out of memory. So for that one, I'm still gonna use U1. I'm just trying to remember what kind of limit I've got. Okay, so U1 is currently running with 64 megs of RAM, which is not a lot, but that's on purpose. So if I do this, we should see it's running with 64 megs. There we go, 25 megs free. Now if I access the metrics API, and I grep specifically for that out of memory thing, and let's also grep for U1 with measures. We just have that one instance. You can see they're just like starting up and doing some stuff with it. It already hit it 20 times per instance. I'll just restart it, see if we can get it to 0. Yeah. Okay, so that instance is now running. It hasn't hit any kind of out of memory situation. If I go in the instance and I run something like apt update, which downloads a bunch of indices and then tries to unpack them in memory, that's gonna explode because it won't have enough RAM. There we go, it reached 56% and got killed. And now if we go back on the host and look at this, now the counter is 1. So that's a pretty useful thing to graph or put alerts on if you've got any kind of external monitoring for LXD. Because it will tell you that something is probably going wrong in that particular instance. If you see it climb if you see it climb a lot, if you're seeing, increase of more than, 10 per hour or something like that, there's probably something really, really wrong going on in there. And either you need to bump the memory a bit, or you need to figure out what's going on, what's eating all of your memory. And that's it. Let me just switch back to the announcement. Here we go. And yeah, that was everything in this release. The storage buckets, instance release date. Didn't show the BGP hold time, but it's really just an internal timeout that you can tweak, so not a lot to actually show. Then the project queries and the out of memory. For the database, kind of same thing. It's an internal change, not much that can be showed. I can say one thing, there was literally so many changes and fixes that I had to increase the maximum length of a forum post so that I could actually publish those release announcements. So very, very busy release as far as bug fixes. And that's it. It's currently rolling out to users. We're doing a pretty aggressive push for 5.5. So the phased rollout should complete within 24 to 48 hours. In parallel, we're also rolling out 501, so the other LTS. The LTS bug fix release here. That one is going to be rolled out much, much slower because it's an LTS, it's got a lot more users, so we need to be kind of careful and not completely saturate our servers, but also give us time to deal with any kind of regression or anything reported by users. And that's it. I hope this was useful. I hope you get some use out of those new features in LXD. If you've got any questions, please put them down below, or go on the forum. We'll be happy to answer them there. And I'll see you in the next video. Thanks everyone. Bye.